Hello everyone, welcome back to the first lecture in Mission 600 Physics Power Play, and in this class I am going to discuss about kinematics in one-dimensional motion. In general, kinematics is about describing the motion in terms of some physical quantities, kinematic quantities, position, displacement, velocity, acceleration, distance and speed. And as you know, any physical quantity will have two kinds of definitions. One is a qualitative definition, the other one is quantitative definition. So qualitative definition gives you qualitative feeling, but then it may not be readily useful to solve a problem. You need to have its corresponding quantitative definition also. In this particular chapter, we will be focusing on quantitative, mathematical description of these physical quantities. That's going to be the most important aspect. And for you to be good in this topic, you have to be reasonably good in basic mathematics, like basics of trigonometry and basics of calculus, differentiation and integration, and also understanding the curve tracing, graphs, slope, area kind of thing, monotonicity, concavity, convexity, that kind, and also solving of linear equations that you would have studied in 10th class, like 2 and 3 variables simultaneous linear equations you will get, and you need to be able to solve it. Quadratic equations you will be dealing with, which generally represents parabola, quadratic expression. Solving of a quadratic equation you should be comfortable, and also certain conic sections, right? In that, primarily circle is usually more important for us. Once in a while you will get a ellipse, hyperbola also, and parabola anyway is covered in quadratic expressions there. So these are basic ideas. I expect that you have a reasonable understanding of it, because it's a final phase. Generally in the first phase, when you are starting your 11th class preparation, you might feel these things very tough for you, because they wouldn't have been covered in mathematics. Now that you are in the final phase, you should be comfortable, but then students might have that phobia, right? First year when I was doing, I was not comfortable, so I am not that good at it. So you need to come out of that mindset. I am sure you will be able to do much better. Alright, let's get into the questions now. The first question, let me read. This is a question taken from 2022 JEE Main. Let me read the wording of the question. A car covers AB distance, the distance AB, with the first 1/3 at a velocity v1 and the second 1/3 at a velocity v2 and third with the velocity v3. v1, v2, v3 are given, and we need to find the average velocity. So it's a very simple idea concept wise. Average velocity is defined as total displacement by total time interval. When it is going in the same direction, 1D motion, magnitude of displacement will be distance. Speed, velocity, we don't differentiate much in 1D because we don't have to worry about the direction there. So that's the average velocity concept. Now if you want, you can just pause for a moment and try to solve yourself, but it is an important model given in Erudo, and many times this question has been asked. Let's read it. So total time, alright, that must be equal to sum of the time intervals that it has spent on the first, second and third part of the track, T1, T2 and T3. So the total time can be written as the total displacement, alright, total displacement divided by total average velocity. This is what I want to calculate. Displacement I don't know, but I know that 1/3 has been covered with v1, v2, v3. So I can calculate corresponding times and sum it up to get the total time. And in that process, you see S gets cancelled out. So you get 3 by V average equals to 1 by v1 plus 1 by u2 plus 1 by v3. Substitute the values of velocities and you take LCM, you will get 1 by 6. And so just cross multiply it, you will get 18 meter per second. So I hope you are okay, comfortable with it. I am not going to spend too much time on solving part of it. I expect that you will be able to do that manipulation. I will be focusing primarily on the ideas. Okay, next question. So the second question in this, let's read. This is also important, taken from the ideas of Erudo again. A car starting from rest, so initial velocity is 0, accelerates at a rate f through a distance s. So 0 to some t0 time, let's say I have assumed that 0 to t0 time, it was traveling with the acceleration f, and it has covered a distance s there. That is first thing. If the total distance covered is 15s, and in between of course it was going with some uniform velocity for some time t, and then later on it is retarding with this retardation of f by 2 to come to rest there. So, this is the overall idea, and we need to find the whatever s value we have to calculate it. So, what are the ideas? You can see that now it is a simple kinematic equation I am going to use. First one is s equal to half a t square, where t naught is the time taken in the first part of the journey there, and I am taking it as a t1 or otherwise t naught there. So, s was supposed to calculate, right, and f is given. T naught I can always calculate, let me read, keep that there. And we also have v equal to at, right, after t time what is the velocity, that means at this moment at the end of the first phase this is going to be the velocity there. So, these two are known to us. So, I will calculate t1 and t2, and next let us go to the t2 part when it was retarding, the final phase of it. I am writing it as a second stage, the first stage and second stage, the middle one I am writing it as third stage because it is easy to compare them. You see time taken in a uniform accelerated motion would be final velocity by acceleration, assuming initial velocity is 0, and uniform retarded motion will be initial velocity by acceleration, final velocity will be 0 there. So, t1 equal to v naught by f and t2 is equal to v naught by f by 2, where v naught is the maximum velocity and also that constant velocity that you get in the middle portion. So, you see that t2 equal to 2t1, this is one important, I think you should get that intuitively. If it takes t naught time with an acceleration a, it will take a double time when acceleration is half. So, that is something that you would get it. So, once I have that, now I will draw this graph. You see from 0 to t naught it is having constant acceleration, and the next moment t, this t has been given, it is going with constant velocity, and then last phase it is going in a retardation but lesser slope there, f naught by 2, f by 2. Now, you know that area under velocity time graph is going to be displacement. Let us say this area is a1 and a3 and a2. a2 equal to 2a1, I am just comparing these two. You see for both these are their right angle triangles. Area of a triangle is half into base into height. You see height is the same for both the triangles, but the base is double compared to the first one. That is why area becomes double. So, a2 equal to 2a1, otherwise 2s, because a1 equal to s there. And we also know that the total distance that he has given is 15s there. So, a1 plus a2 plus a3 is the total area under velocity time graph, and if you sum it up it is going to be 15s. So, a1 and a2 we just got it, a3 will be equal to 12s, which is going to be the area of this rectangle where it is going with constant velocity. V naught into time you can write, otherwise simply calculate area of the rectangle, you will get that 12s equal to v naught into t, but v naught equal to f t naught if I substitute there, and also t naught we can calculate from equation, that is root over 2s by f. So, squaring it either side you will get s equal to 1 by 72 into ft square. So, that is what we have. This is a very nice question, graph related question, area under graph and all that. So, I think you should spend good amount of time solving these kind of questions, very important model. Okay, let us go on to the next question. This question is also basic idea, just common sensical question. You need not know much about physics about it to solve. A simple aptitude based question, let us read it. A person standing on an open ground hears the sound of a jet aeroplane coming from north at an angle 60 degrees. So, for me here when I am standing here, sitting here, the back of me is east. So, that means this is west. So, this is going to be north. I see that from north, from above at an angle 60 degrees with horizontal, I am getting the sound. I feel the sound is coming from there like this. So, the person who is standing here, he feels that it is coming from north. So, for him this is north, okay, north, from north it is coming, but not horizontally, at an angle 60 degrees from above it appears to be coming, alright. But he finds that the aeroplane right vertically above his, so he sees the sound is coming from there, but he sees the aeroplane is right above him. So, what would have happened was, probably let us say the jet that we are taking here, it was here at the when the sound was produced, and the sound is travelling along this line 45 degrees line, that is called line of sight. By the time this comes from A to C, the sound pulse has come from A to C, the jet has reached from A to B right above the person, that is why he sees that his aeroplane is here. Aeroplane is above, but it was produced some time back. So, the pulse will travel along this line, green line, whereas the aeroplane goes along the horizontal line like that. So, by the time plane goes from A to B, the pulse has moved from A to C, that is a basic idea. and now you can have a little bit of trigonometry, right? This is going to be v into t, where v is the velocity of the pulse. This is going to be vp into t, that is velocity of the plane into time, same time it has taken. Using this triangle, right angle triangle, sine 30 degrees equal to opposite side by hypotenuse, you can substitute there. Sine 30 equal to AB upon AC, which is going to be Vp into T by V into T, and from there we will get Vp equal to 1 by 2. So I hope it is understood. It's simple idea, no need to actually have any kind of conceptual clarity in such a high level. It's just commonsensical aptitude based question, visualization part of it. So I hope you got it. Next question let us go to. So this is escalator question. It's actually very simple question, but somehow I don't know why students seems to have a little bit of confusion about it. That's why I just wanted to take. Anyway, question is very simple. Let's read. A person climbs up a stalled escalator. Escalator was stationary initially. Stalled escalator. Escalator was at stationary. I am keeping that is the first case there. And he keep on walking, walk up the stairs there. So he is walking with a speed v1, let us say, and it took him 60 seconds. So t1 equal to 60 seconds. That is what he has given. Now the second case is not walking, he is just standing on the escalator, but the escalator is going with the velocity v2. So escalator is going with the velocity v2, but the person is standing on it, but escalator will carry him with the velocity v2. So even the person will have a velocity v2. He is going to have a velocity v2. Okay, both of them are going to have velocity v2. Now he is able to reach the top after 40 seconds, meaning v2 equal to s by t2, same displacement he has to cover, but t2 is 40 seconds, you have it. The third situation is how much time is taken by the person to walk up the moving escalator. So escalator is going with v2 velocity, and he also starts moving with velocity v1 with respect to escalator because of his own effort. Now we are going to use principle of superposition. Only because of his walking he gets v1 velocity. Only because of the escalator moving he is getting v2 velocity. When both of them are simultaneously added, you get that the person velocity is going to be v1 plus v2. So now what will be the time taken? That is what the question is about. So I hope you understood that. Now let's do the simplification. Calculate t1 from the first, t2 from the second equation, and substitute in the third equation. t3 equal to s by v1 plus v2. S by v1 is t1 is v1 by t, s by t1 is v1, s by t2 is v2. So s will get cancelled out anyway. You will get this t1 t2 by t1 plus t2, like harmonic mean, but exactly it is not harmonic mean because 2 is missing there. But anyway, you can simplify it. It's a very simple question, and you should not miss out this question, this kind of question. So you will get 24 seconds as a time there. Right, next question. Let me read the statement. A person moved from A to B on a circular path as shown in the figure. The distance travelled by him is 60 meters. You see distance. I hope that by now, after covering so much of syllabus, you understand the difference between distance and displacement. Distance is 60 meters. Distance is 60 meters, the length of the path that he has travelled. Then the magnitude of displacement would be, and they also gave cos 135 degrees just for the calculation purpose. So now you see distance is going to be arc length, r theta, where theta is in radian, but displacement is going to be shortest distance. Alright, though I said it is a kinematics in 1D, I have just taken this question because it's a fundamental basic question here. It is 2D motion, but I am using it here itself. So initially it was here, this is the initial position and this is the final position. You simply join the initial position to final position, that is going to be the shortest distance, that's a displacement there, s there. So we need to calculate a displacement, and we have this trigonometry, and a small little bit of trigonometry you have it. It is isosceles triangle. For an isosceles triangle, median altitude both are the same. So this is going to be r sin theta by 2. You see in this right angle triangle you have r is the radius, which is the hypotenuse per triangle. I require the opposite side. Opposite side is going to be sine component. So r sin theta by 2 is this part. The same way this is also going to be r sin theta by 2 because this point is going to be midpoint, and so total displacement is twice of r sin theta by 2. In fact, some students remember it as a formula. Simply you can remember it as a formula. Now let us take the ratio displacement upon distance. If I calculate, radius will cancel out because they didn't give the radius there. So sin theta by 2 by theta by 2. So it's a very nice simple formula. S equal to L into sin theta by 2 by theta by 2. It's a very common formula, you must have it. Now what is theta? They had given 135 degrees. 135 degrees is pi by 4 is 45. Thrice of it is going to be 135. So 3 pi by 4 is theta by 2. This 2 goes up. into sine of 135 by 2 is sine 67.5. Sine 67.5 I don't know, it's not a standard value. So for that I will use a simple trigonometric relation, sine theta by 2 equal to 1 minus cos theta by 2 under root, I am sure you are aware of it. Cos theta they had given minus 0.7, so I will substitute there, minus of minus plus it will become 1.7 by 2 meaning 0.85. 0.85 under root I have it, 0.85 under root is how much? 0.81 would be 0.9, 0.85 meaning 0.9 more than that, slightly little more, 0.9192 something like that, you will get this value. So that I am going to use here. Now you can substitute s by 60, 60 was the distance given, that is equal to 8 by 3 pi into this is 0.92 something like that. So 3 is 3, pi is 3.14. I suppose this is almost cancelling out, 3 pi and this will be approximately cancelling out, then you will get 0.1 here, 0.8 into 60 meaning 8 6 are 48, close to 48 you will get it. 7. This is the question, you need to do it with approximation there. So you got it, very simple idea. Let's go to the next question there now. In a car race, this is also good question, like in the sense like simple problem based question only. In a car race on a straight road, car A takes a time t less than car B. So t less meaning it is going earlier, B takes more time than A, and how much more time? T time it is taking more at the finish, and passes finishing point with a speed V more than car B. Okay, so compared to B, A will go with the speed V more. So V is the excess speed, not the velocity, excess velocity that you have. Both the cars starts from rest and travel with the constant accelerations A1 and A2 respectively. Throughout the motion we are assuming that they are going to go with the constant velocity, constant acceleration. So then V is the excess speed, we need to calculate there. So let me draw the diagram here. This is going to be the diagram. Let's assume this is the initial point, starting point, this is the ending point. So they will cover the same distance anyway, because in a race it is for any race you see distance covered would be same, no? That need not mention it. So both of them are here, A and B, and starting from zero velocity, but they are having different accelerations. First at TA, A will reach the crossing line, but B will be behind still. And by the time B comes here, A would have already gone. Then TB is the time where TB is T extra, TA plus T. And whatever velocity VB is reaching, that is actually less, V less than VA. So VB equal to VA minus V, we got it. That's a basic idea we have. What are the ideas we are going to use here? Number one, both of them are going to cover same displacement, number one, because same race track, na? That is one. And they gave that VA minus VB equal to V, and TB minus TA, B takes more time, TB minus TA equal to T. These are the three ideas we have to use, and let's start with them. First one, displacements must be equal. Displacement half AT square equal to displacement here, because initial velocity is 0. So half AA TA squared equal to half AB TB square. Then from there you will get TB by TA equal to root over AA by AB. That's one equation. Then we can use component of either side, you subtract 1 there. So TB minus TA by TA equal to root AA minus root AB by root AB. But TB minus TA is nothing but T, and you can substitute there and do the cross multiplication. You will get T into root AB by root AA minus root AB going to be TA. Once I have TA, I can calculate TB using TA plus T. TB is more, no? And if you substitute there, you will have this. LCM is going to be covered, same you will have it. So this is going to be, finally what happens is TA depends on root AB and TB depends on root A. It's like inverse relation, you have it. So now that I have times of travel for both of them, then I can calculate VA and VB. VA equal to AA into TA, VB equal to AB into TB, calculate both of them and subtract it. When you take the subtraction, you should get V, that's what he was saying, VA minus VB equal to V, that was given. So now this is what I am getting here. What I can do is, I can take out root AAAB here. If I take root AAAB, I will have root AA here, and here root AB. In the denominator also you have the same thing, they get cancelled out. So you will get root AA into AB into T. That's a manipulation, you have it. It's a good little manipulation question, but conceptually it is very simple only. A bit three ideas we have to use here, that's a basic idea. So I am selecting questions which are generally slightly tougher level in mains examination. There are many questions which are straightforward, we can solve it. But these are the questions which requires a little more analysis there. Okay, now next. This is a simple graph based question. All the graphs below are intended to represent the same motion. So, same motion they are representing, okay, same motion. One of them does it incorrectly, okay. One graph is incorrect, out of all three have to be, out of all four, three will be correct, consistent, but one is off. So, we need to identify which is not going to match with the other three. Okay, now first graph you let us analyze. When position is 0, you have a maximum velocity, positive sometimes and negative sometimes. So, sometimes it is having positive velocity, sometimes it is having negative velocity, and there is a point where it is having 0 velocity also. But if you look at here, this entire graph if you focus on, nowhere you see the slope is 0. Slope is not 0, you see here, slope is not 0 here, slope is not 0 here, and later on it is going like this, but then it is supposed to return back again, and it is not coming back. Anyway, distance keeps on increasing, it will never decrease, but you see that in the entire graph there is no slope 0. So, these two are inconsistent with each other, only one of them is going to match with others. Let us go with the other graphs. Look at the D option, you see, on the one side you have positive slope, on the positive value, velocity is positive, and on the other side you have negative value. So, at this point velocity is 0, that looks like it is consistent with this, okay, both are consistent. What about position versus time graph? If you see, here you see slope is positive, and here slope negative. So, initially velocity is positive, later velocity is negative, at the highest point velocity will be 0 there. So, this also seems to be consistent with the other A and D. That is why A, C, D are together, they are representing as a common motion, but D is not in consistence with that. So, D will be the answer because they are asking you to choose the incorrect option there. Okay. Next one. Which of the graph corresponds to an object moving with a constant negative velocity? So, you require constant and negative velocity, negative acceleration and positive velocity. Velocity has to be positive and acceleration has to be negative. So, you see velocity into acceleration is negative here, right. In 1D motion, whenever you have velocity into acceleration is negative, that means it is going to be slowing down. It has to slow down continuously. Whenever acceleration and velocity are opposite to each other, it will always have a retardation. So, but if you look at the first graph, it is slowing down for some time and after that it is speeding up. So, this cannot be the graph. This graph cannot be what is being represented there. And the second graph you see slope is increasing. That means acceleration is increasing. Over here acceleration is said to be constant. In fact, here also you see acceleration is variable. So, acceleration is not constant here, slope is not constant, that way you can remove it. In fact, velocity is increasing, velocity is supposed to decrease here. There are two problems with that. Okay. What about the C option? Yeah, in C option velocity is decreasing, in D option also velocity is decreasing with distance. So, C and D are fine with the fact that both are representing velocity is decreasing. Okay. But when you look at the slope here, slope of acceleration, if you look at V dV by ds, from there you can write the slope equal to dV by ds, which is A by S, but A is negative and constant. And so, slope is inversely proportional to distance, no? And if you take the magnitude of slope, more the distance, lesser should be the magnitude of slope there. That means it should become lesser and lesser steeper. As S increases, lesser and lesser steeper it should be. That means this is going to be the answer there. So, by observing the slope, we are able to get to that conclusion there. Okay. So, yeah, that is what you have. Next one. A helicopter rises a helicopter rises from rest on the ground vertically upwards with a constant velocity acceleration g. Okay. A food packet is dropped from the helicopter when it is at a height h. The time taken by the packet to reach the ground is close to g is close to. Okay. How much is the time taken for it to reach there? Yeah, let us read the question. A helicopter rises from rest on the ground vertically upwards with a constant acceleration. Okay, initially it is at rest and it starts rising up with a constant acceleration g upwards. A food packet is dropped from the helicopter when it is at a height h. Okay. The time taken by the packet to reach the ground is close to. Okay, so one important concept is the concept of inertia. When the packet is released, alright, are dropped, the velocity will continue, right? Whatever is the velocity it is having inside the helicopter, the same velocity will continue, but acceleration has no inertia. Acceleration can suddenly change. Inside the helicopter it is having g acceleration upward. The moment you drop it, acceleration becomes g downward. So acceleration will change suddenly, but velocity doesn't change. That's a point that we need to focus on. So let us look at the entire motion here. Let me take out this part over here. So initially it is here, alright, helicopter is accelerating up to this point. Now you see g is the acceleration. The food packet was also accelerating upward. After traveling h distance, helicopter and the food packet, both of them are going to have v0 into root 2gh velocity. Okay, so that's the velocity they are going to have. Now the helicopter continues its motion, but the food packet is dropped. When the food packet is dropped, it will continue with the velocity to start with, but then because of gravity it is going to return there. And how much distance it is going to go to come to rest? Same distance by symmetry. You see, if it takes h distance to go there, and after that it is going to take h distance to slow down, because there is a symmetry about that point A there. So by the time it goes to h distance, it will come to rest there. You can actually do kinematics, but I am using the symmetry idea there. So now after that it is going to come to rest momentarily and then start falling to a distance 2h. So now what are they asking? What is the time taken for it to reach the ground after it is being released? The first one is going to be root 2h by g, alright, v0 by g, v0 minus 0 by g. Initially v0, finally 0, v0 minus 0 divided by acceleration will give you time. That is time taken from A to B, root 2h by g. Then from B to C, final velocity will be root 2g into 2h. 2h distance it has to come now, and initial velocity is 0. So initial velocity is 0, final velocity is known to you, difference you can calculate, root 2g into 2h divided by g is going to give you the time taken from B to C. You sum it up, you will get the total time taken, that is going to be 2 plus root 2 times root 2h by g, that is going to be 3.4 approximately times root 2h by g, root h by g. So that's the answer you got there. Next question. Right, let's read the question. A tennis ball is released from a height h, and after freely falling on a wooden floor, it rebounds and reaches a height h by 2. So you are dropping from a h height and then it hits the ground and goes back up to only h by 2 because there is a loss of energy. It's not elastic collision you have there. Velocity versus the height of a ball during its motion may be represented as, okay. So as a function of height they are giving, height is y, of course they had given it as h there, but I am taking it as y there. Initial height is h and height any time is, let's say, y. So you see this is the expression you have. Displacement from the top will be h minus y, that's fine. So v square equal to 2gy, that you get it, it's a quadratic expression, meaning definitely you are supposed to have a curved graph, it's a parabola. So that means this first graph cannot be the answer, you can leave that. And then look at the last graph has got a problem here, you see, when y equal to 0, meaning when it comes to the ground, it is having 0 velocity and there is no collision effect here. Because of the collision, suddenly velocity direction should change. When y equal to 0, velocity should change suddenly direction. Initially downward, negative velocity, suddenly it should become positive, upward velocity. But here you see smoothly velocity is changing at this point. And just before collision, just after collision, velocity is 0. That's wrong. So D option is also wrong. Now we need to focus on B and C. And now if you look at both of them, curved linear only. When we write dv by acceleration, let's write it v dv by dy, that's going to be minus g, obviously it is downward. So dv by dy is going to be minus g by v, that's the slope of the graph, no? And let's take magnitude. As v increases, it is supposed to have lesser slope, magnitude wise lesser slope, meaning lesser steepness should be there. As v increases, it should have lesser and lesser steepness. Here you see, as the v increases, it's becoming more and more steeper. So that is not correct, okay, that is not correct. Over here, as v increases, you see it is lesser and lesser steeper. So C should be the answer there. I hope you got that. Next question. A ball is dropped from the top of a 100-meter high tower on a planet. In the last half a second before hitting the ground, it covers a distance of 19 meters. acceleration due to gravity near the surface of the planet is. So this is a very simple question. Total, let's say total time of flight is t naught, half g t naught square equal to 100 meter, right? You started from here, dropped from with 0 velocity, and it has covered 100 meter totally. That's what the total 100 meters they had given. Total time is going to be t naught, meaning half g t naught square equal 100. Okay, that's fine. In the last half second, it is said that it is traveling only 19 meters. So that means up to half second, that means that if I take t naught minus half from the beginning, and in that interval it is going to take how much distance? 100 minus 19, which is going to be 81 meter. That's the distance covered. So if I use half g again, t minus half whole squared, that's going to be 81, and then you take a root and take the ratio of the two, you will get t naught minus half by t naught equal to 9 by 10. Otherwise you can just divide it, 1 minus 1 by 2 t naught equal to 1 by 10, or 1 by 2, that is going to be 9 by 10. Otherwise 1 by 2 t naught is 1 by 10. From there you will get t naught equal to 5 seconds. Once you get 5 seconds t naught value, you can substitute in equation 1 to get g there. That's coming out to be 8 meter per second square, meaning it is not Earth, some Mars or something like that probably. Okay, I hope you understood the question. Next, from the tower of a height h, a particle is thrown vertically upwards with a speed u. Time taken by the particle to hit the ground is n times that taken by it to reach the highest point of its path. The relation between h, u and n is, okay, so we are projecting it from here, it goes up and then it falls back onto the ground. Let us say u is the initial velocity and they had given it, and v is the final velocity with which it is going to hit the ground there. And v you can calculate using conservation of energy. So loss in gravitational potential energy mgh equal to gain in kinetic energy, half mv square minus half mu square. When I write COME, right, it is conservation of mechanical energy. So v you will get in terms of u. And then time taken is what? From a to b, final velocity minus initial velocity by acceleration. Final velocity is 0, initial velocity u divided by acceleration minus g, so it becomes u by g. It's like time of ascent in upward motion there. Then from entire a to b and then b to c, if you calculate, that will be final velocity minus initial velocity by acceleration. Final velocity is minus v, initial velocity is u, minus v minus u divided by acceleration minus g. So you will get v plus u by g. This is the time taken from a to b and then to c. But they said that it should be equal to n times that from a to b. If you compare them, you will see that v equal to n minus 1 into u. Square it either side and substitute this v value over here, which is u square plus 2gh, and you take u also to that side, n minus 1 whole square minus 1 into u square. So this can be written like a square minus b square form, a plus b into a minus b. Plus will give you n, minus will give you n minus 2. So 2gh equal to n into n minus 2 into u square will be the answer. That is C option. Alright, next question. A small ball of mass m is thrown upward with a velocity u from the ground. The ball experiences a resistive force m into kv square, where v is its speed. The maximum height attained by the ball is, okay. So maximum height, at maximum height what is the velocity, what is maximum velocity at maximum height? It's going to be 0, no? And after that it is going to return back. So whenever it is retracing the path, at that moment it is going to have 0 velocity momentarily. That's one thing. And then after that, in addition to gravity, there is the resistive force. Resistive force will be opposite to velocity. So if I study upward motion, gravity is anyway always mg, but even resistive force will be downward because it is opposite to velocity. Now if you calculate the total force, mg plus m into kv square divided by mass will give you acceleration. That's acceleration, you have it. Minus because it's opposite to velocity, g into kv, g plus kv square, that's going to be acceleration there, which I will write as either dv by dt or otherwise v dv by dy, because they are asking about the height, I will write it as v dv by dy there. Now rearrange the terms, just simply integration here. Why am I doing integration? Why can't I use kinematic equation? Think about it. Yeah, because acceleration is not constant here. So kinematic equations are valid only when acceleration is constant. Now this right hand side integration is very simple. You see that you have v dv in the numerator and g plus kv square. Just take g plus kv square as some other variable, differentiate it. You will get v dv, that is present there on the top. So you will get nice logarithmic function there. Substitute the limits, alright. That minus will be absorbed when you take the initial minus final limits there. So from there you will get y max equal to 1 by 2k into ln of g plus kv square by g, g plus kv square by g, meaning this one you will get it, alright. Yeah, next question. A stone is dropped from the top of a building. When it crosses a point 5 meters below the top, another stone starts to fall from a point 25 meters below the top. Both the stones reach the bottom of the building simultaneously. So finally they reach bottom simultaneously, then height of the building equal to. So I am just showing that in the diagram. Initially it is at the top of the building. Let's say this is 5 meter mark and this is 25 meter mark. Gap between them is 20 meters. So this is t equal to 0. After that the particle has come here after delta t1 time, crossing 5 meter mark. At that moment the second stone was dropped from 25 meter mark. That is what he is talking about. So at this moment this second stone has got 0 velocity, the first stone has got v1 velocity because it has travelled 5 meters there and covering delta t1 time. So actually you can use kinematic equation to find the delta t1. Half g into delta t1 square equal to 5 meter, you will get delta equal to 1 meter. So it's 1 second, it's very simple. Half gt square 5 meters, meaning you will get 1 second in a vertical motion anyway. It's very commonly used. So time taken, we got it 1 second. Alright, fine. At 1 second, what will be the velocity of the particle also? You can calculate, that's 10 meter per second. At this moment, this first stone has got 10 meter per second covering 5 meters distance, and this stone has got 0 velocity, and right now it is at a distance 25 meters from the top. That means what is the separation between them? 25 minus 5, that is going to be 20 meters. So let's study this, alright. Let's study this. V1 equal to 10 meter per second, V2 equal to 0, and that's the situation you will have it exactly at t equal to 1 second after the drop of the first stone. And we can calculate relative velocity between them. 10 minus 0 will be 10 meter per second, and interestingly this is something you should know. Acceleration of one projectile with respect to other projectile is going to be 0. Both of them have downward acceleration g, so relative acceleration is going to be 0, and relative displacement is what is the separation. Finally they will meet. Initially they are separated by 20 meters. So relative displacement is going to be 20 meters, and if I want to calculate a time interval, relative displacement by relative velocity, that's all. There is no acceleration with respect to each other there. So you will get 2 seconds. After 2 seconds they will meet, and they are saying that when they meet they reach ground also. Simultaneously they are reaching the ground, that's what they are talking about. So when will they reach? After 2 seconds the ground there. That means what is the total time of travel of the first particle? That is going to be 3 seconds. Once I know the time taken, I can find the height. H equal to half g into 3 square, you will get 45 meters. So that's the question we have it. So I hope you understood. This is the first 14-15 questions that I have taken. I try to explain them. So you please go through them. You suggest me any suggestions, ideas, how you want me to do it. You want me to explain some theory, you want me to take some higher level questions, you want me to just go with it. I have certain idea that whatever good questions are there from PYQs, I want to cover them first. Later on I would like to go for the second phase. Second phase I will explain to you anyway later. So this is about the first session that we have. I hope you understood and you got the clarity about it. Thank you very much for your time. Until next time tomorrow, goodbye. See you.